Welcome to hell. Welcome to A-level vectors. After marking this question last summer, the examiners said this in their report. This question proved to be a differentiator between candidates. Some were unable to make any meaningful progress. Oh dear. It was much more common for candidates to take an unnecessarily complicated algebraic approach. Is that what you did? It would be helpful for candidates to bear in mind that a 4-mark question should not involve pages of work, and there are more efficient strategies. Well, I'm going to show you these now so that you don't waste your time this summer. Figure 2 shows a sketch of the straight line L. Well, there's the straight line L. L passes through the points A and B. Relative to a fixed origin O, the point A has position vector this, and the point B has position vector this. Let's draw on the diagram the origin and show the vectors O to A going this way and O to B going this way. Those are the position vectors that we're given in the question. And we're asked to find the vector that takes us from A to B. Notice the direction of this arrow, that's important. We're trying to find this vector that goes this way from A to B. So we're starting at A and we need to end at B. How can we take that journey? Well, we can go from A to O this way, and then from O to B this way. Notice that when we go from A to O, that's in the opposite direction of the arrow here. So if we want to use O to A, which is the vector we've been given here, we need to add in an extra minus sign. We don't need to do that for O to B because we're going in the same direction as that position vector, the same direction as the arrow. So a plus sign here. So we've got minus O to A, so minus the vector here that we were given. I've just written that as a column vector because it's easier to write for me. And O to B is this vector. So all we need to do is do this little bit of subtraction here and simplify the result to get A to B. Let's look at part B. In part B it says, given that a point P lies on the line L such that the distance A to P is twice the distance from B to P. How do I know that's a distance? Because of these modulus signs. So it's not saying the vector A to P is twice the vector B to P. No, it's saying the distance, the length, the magnitude, the modulus of that vector is twice the length, the magnitude, the modulus of this vector. Find the possible position vectors of P. There's some clues here. Possible and position vectors in plural. So there may well be, we're expecting to get more than one. In fact, I think there are 2 cases here. Let's consider them carefully. It might be that the point P is between A and B. Notice what this statement is saying. It's saying the distance from A to P is twice the distance from B to P. Think carefully about what that means. Think carefully about which length is longer of A to P and B to P. Well, it's A to P. To get A to P, we have to multiply B to P by 2. So, if this is B to P, if that's one part, then to get A to P, we have to double it. We'd get 2 parts. How many parts altogether? 2 parts plus 1 part makes 3 parts here. That will be important. Notice there's also another case, case 2, where P is actually not between A and P, but it's in fact this side of B. Notice still, the distance from A to P is double the distance from B to P. So if this is 2 parts, this is 1 part. Let's consider case 1 in detail. Case 1 was where P lay between A and B, like so on the diagram. We're asked to find the position vector of P. That's the vector that takes us from the origin to P. How can I get starting at the origin to P? Well, I could go from O to A along this vector, and then I would have to go from A to P. But A to P is 2 parts out of 3 parts total of the length A to B, the vector A to B. So it's 2 parts out of 3, 2/3 of the vector A to B. That vector A to B should be familiar to you. That's what we worked out here in part A. We know what O to A is. They told that us in the question. That was the position vector. So that's O to A plus 2/3 of A to B. That's what we worked out in part A. So we can plug that in here. If we do the number crunching on this vector, we end up with this. And if we add these two vectors, we end up with one possible position vector for P. That's case 1 done. What about the second case? Well, that was where P didn't lie between A and B. In fact, where P was on the other side of B. We're trying to find the position vector of P. That's the vector that takes us from the origin to where P is. So we need to go on a journey starting here and ending here. How can we do that? Well, one way of doing it is to go from O to A and then from A to P. Let's think about that. O to A, well, we know that journey. We're given that here. But what about A to P? How can we get that? Well, we know if this is one part, this is two parts. So how many parts would this section be from A to B? Well, it's going to be the same. It's going to be one part, right? So here, we've really got two parts, two lots of the vector A to B. So we've got O to A plus 2A to B. And we worked out that vector A to B in part A. So we can plug that in here. And if we do the number crunching, we end up with this, which can simplify to this. So we've got two possible position vectors of P. No need to use any vector equation of a straight line here. That would be overcomplicating it for 4 marks in this question.